Today we'll start measures of variation. So in this, firstly we will learn about range, and we have seen about range when we were discussing the frequency distribution. So and the formula is same over here, that is maximum value out of all the data minus the minimum value, right? So but one drawback of range is that it does not consider all the values, because it just considers the maximum and the minimum, but the mid values, all the center values are not considered, so it does not give us the exact result. Okay, so we go for some other measure of variations also, that is we will discuss the standard deviations. So before that we need to know about the coefficient of range also. Coefficient we use when the both of the, you can say, data values are of different, you can say, different units are there, right? The units that cannot be compared, so there we use the coefficient. But the formula for finding the coefficient of range is maximum value minus minimum over maximum plus minimum. Pretty simple, right? Okay. Let's go for the important concept, that is another measure of variation, that is standard deviation. So what is standard deviation? It is basically the distance. This is the distance, that how much distant your data value is from the mean. Like suppose there your mean exists, right? And your data value is over here, right? So this distance is the standard deviation. Okay, the distance of your particular data value out of all the values, so that particular value is how much distant from your mean is the standard deviation. And another thing is that distance is the average distance, not the exact distance. Okay, so here it measures the average distance your data values are from the mean. And in standard deviation formula we use the mean also. Okay, mean is very important for the standard deviation, and this is why both the mean and the standard deviations are affected by the outliers. We have seen that how the outliers are found, what is the formula, and that outliers strongly affect both the mean and standard deviation. Standard deviation, because here you can see in the formula we use the x bar, that is mean. Okay, so both standard deviations and means are greatly affected by the extreme large or extreme low values, that is the outliers. Okay, so here some important things about standard deviation you have to remember is that it cannot be negative. Why cannot be negative? See the formula. Here we have the square root, and inside the square root, if the value is negative, then this is the imaginary case, not the real numbers, right? So our standard deviation cannot and never be negative, and it is also never zero unless all the entries are same. Like all these, our mean, all these x's, all the data values are same. If they are not same, which is just rarely a case that they are same, so if they're all same, that our standard deviation is zero, that is there is no deviation from the mean. The mean is, suppose the mean is here and all the data values are lying over here at the same position. The mean is 4 and all the data values are also 4, right? In that case, it's a common sense that no deviation is going to be there. So there the deviation is 0. But when the entries are not same, their deviation cannot be 0. Okay. It is affected by outliers. We have seen this. Sample standard deviation is denoted by small s. We have two deviations. First one is sample standard deviation. Second is population standard deviation. Formulas are just a little change, nothing different, but we represent sample standard deviation with small s. Okay. So the formula for the grouped data is, let's see the formula. This f is, you can say, the frequency of each data value, x minus is x is our data value minus x bar is mean, right? And since we're discussing for the grouped data, which means that here if we are given the classes, then from classes we have to get our midpoints. We have discussed this many times. So those midpoints are represented by x in case of group data. So here the x will be our midpoints. But if the data is ungrouped, like we are not given the classes format, in that case these x will be our simple data values that we will be given. Okay. And after subtracting our mean from all the data values one by one, we take the square of those values that come after the subtraction, and then we multiply the value that comes after square with their respective frequency, and then whatever comes we take the sum of all those values. So the sequence of execution is from the inner side. Like firstly we solve this part, then we take the square of all the values, then we multiply with frequency, and then we take its sum divided by n minus 1. N means total number of values, that is sigma f minus 1. This is for group data, but you can also use this for the ungrouped data. The only difference is that in ungrouped data, this x will be not our midpoints, right? Because we will have the simple data values, not our classes. And here this f will not be used. If we are not given the frequency, then we don't need to multiply by f in that case, right? So we have discussed about finding the midpoints as well as these multiplying with frequency in the previous lectures. In this case, we will see this formula for the ungrouped data. Same formula, but frequency won't be used. So see over here, find standard deviation of 4, 7 and 7. Now you can see these are not any classes, so these are my individual x values. I don't need to find midpoints, right? And my formula will be what? F will not be used because we are not given f anywhere. Okay, so make the columns of your x. Then as I have told that we start from the innermost expression, right? So first we take x minus x bar. For this we need our mean. Mean is what? Sum of all values by total number of values. It gives us 6. Okay, so our mean is 6, and then subtract 6 from each data value. 6 minus 4 is minus 2, 6 minus, you can say 7 is minus 1, and 6 minus 7 is minus 1, right? You can see I'm not using minus 1 with some values because ultimately they're going to be squared, right? So they have to be get positive, no issue. So after taking it square we get this, and you can see from the formula, after this part we do what? We multiply with f. Since this is ungrouped, so we don't need this multiplication step with f, and we take the sum of all the squared values. This sigma means sum, right? So here we are taking the sum of all these squared values, that is 6, 4, 5, 6. Okay, now we are done with the formula, so we have to just put the values. This sigma x minus x bar whole square is 6, n minus 1. N is how many values? 3 values. 3 minus 1 is 2. 6 by 2 gives us 3. Solving it we get s equals 1.7. This s is the standard deviation. So our these data values are 1 point, you can say 1.7 standard deviations away from the mean. Our mean is 6, so these values are 1.7 numbers away from the number from the mean 6. Okay, this is how we find the standard deviation. Okay, sample standard deviation, not population. So one another thing, when we discuss for standard deviation, we must need to know about variance. Variance is nothing so different. The only difference in finding the variance will be that without taking the square, whatever lies inside the square will be your variance. Okay, this is pretty simple. So without square is your variance. If you are just told this is your given data and you are told find the variance, you are not told anywhere find the standard deviation, but you are told find the variance. But you must know that since this variance is the square of standard deviation. Square of standard deviation. How? Because if you take its square, you get 3. And as I have told, that inside the square what lies is your variance. This square is not a part of your variance. So for removing it, we take the square, of course, right? So you can say that variance is the squared standard deviation. So this 3 is our square, this 3 is our variance, right? So if you take the square root, it becomes your standard deviation. Very easy to find the variance. So now after knowing that what is variance, we also need to know about the coefficient of variance. For that we have a formula, coefficient of variation. Coefficient of variance equals S is what? It is our standard deviation over this is mean value, whatever the mean of that particular data, into 100. This gives us that how much variable your data is, and as the variation of the data increases, as the variance increases, your consistency of the data decreases. This is general concept, right? So if you are given two data sets and you are told to find that which data set is more variable, it means that which data set is less consistent, right? So in order to find the variability, you need to use this formula. It will tell you that which data set is more or less variable, right? And ultimately from this formula you definitely need to find standard deviation, and from that you can get your variance, right? So standard deviation over mean of that data into 100. This gives you the coefficient of variation. Okay, and where the coefficient of variation answer is higher, there your coefficient and there your data is more variable and it is less consistent, right? So next thing is for the population standard deviation. This is just same thing, same concept. It is just for the case of population. Like the whole thing is under consideration and not a sample, or not you can say a sample is basically part of the population, small subset of population. It is the whole set, right? So for we denote the you can say this standard deviation for population with this sign. Okay, so you have to remember the sign of this, as well as the one important thing over here is we are representing mean by mu, because in sample mean we represent by x bar, and in population mean we represent it by mu. You can say the formula for finding the mean remain the same, nothing different, just the representation differs. Okay, just to clear out that yes, we are using population and not the sample. And here you see that previously we were using small n minus 1 for this case of sample. Here we use capital N for the population, and means number of elements. This is the only difference, like representation of this, and this is not n minus 1 but capital N. For the sake of variance, we represent sample variance with a square. Why a square? Because I have told you, I have shown you that variance is the square of the standard deviation. Like in the previous case, we have seen that inside the square root was 3. So if you take the square so that the square root goes away, so we got to know from there that the squared standard deviation is our variance. So we take the square of the standard deviation, it gives us the variance. For population, variance will be represented by this sign. So the formula is the same, you can see, but here we are just not taking the, for the case of I'm discussing here for a sample, we are not taking the square root. Why? Because if we, you can say, take the square over here and take the square over here, that square root gets cancelled and here we get our square. Similarly over here, the same formula standard, you can say as a standard deviation, but no square root because we have taken square on both the sides, so square root gets cancelled. Okay, I hope you have got this thing. Another thing is that closely grouped data will have small deviation. Definitely the data is closely grouped, like here the mean is and closely all the data values lie. It means the deviation, the distance is, gap is less, right? And if the data is spread out, like here is our mean, here is some other value, then another value, then another, like this, then the data is largely spread. In that case, we can have the chance that our standard deviation can be large. Okay, so in this lecture we have seen that how to find the standard deviations, variance, and their coefficient. Okay, so I will see you next time. Thank you.